I'm Anil Kumar. Welcome to my series for middle school students. We'll discuss factors and multiples, and we are going to use UMCL model for problem solving. UMCL stands for Understand for You, Make a Plan, Carry Out the Plan, Look Back. UMCL, right? So the approach here is going to be that whenever we are going to read a question, we are going to first make a plan after understanding what the question is. So first we'll understand, right? And once we understand the question, where we'll write what is given and what we need to find. And how to find will be decided in make a plan. Once we make a plan, we'll carry out that plan and we are going to get some results. Analyzing those results, looking back into, did we get what we wanted? So that is the kind of question which you need to ask, right? So when we are trying to understand the situation, we write what is given to us and what we need to find, right? So what is given and what to find. And when we want to make a plan, we are discussing strategy or some basic formula, right? So when we carry out this plan, we are solving equation. And when we have to look back, we're actually analyzing or checking results. So that is UMCL method. We have 4 very interesting questions here, where the base is to understand factors and multiples, common factors, greatest common factors, and lowest common multiples. Those things will help you solve these questions. You can pause the video, copy these questions, try them out. We'll take them one by one. The very first question here is Anil, Ben, and Sophia work part-time. Anil works every second day, Ben works every third day, and Sophia works every fourth day. Today, they all work together. When will they work together again, right? So that is the question for us. So we'll follow this plan, UMCL, as I was discussing. So we'll divide this into 4 parts, our space into 4 parts. Now let us see first, what are we given, right? So first thing is we have to look into what are we given. We are given that Anil, Ben, and Sophia work part-time. Anil works every second day. So we are given Anil works second day. Ben works every third day. Sophia works every fourth day. Correct? And today they all work together. When will they work together again, right? So we are looking for same day. Next time. So that is what we need to find, correct? So that is what we need to find. So that is the other thing, correct? Now, we have to see or make a plan how we can actually figure this out. So we realize that we are trying to find common factors for the 3, right? So when do they work next time? In fact, we are trying to find the common multiples, I should say. That is what we are trying to find. Common multiples between second day, third day, fourth day, right? So then they will be working together on one particular day. So that is the strategy, right? So what we can think about is today we say let today be starting day, right? As given here, and say if I write 1, it means after 1 day, 2, that means after number of days, correct? So that will mean days after today. So we are looking for a common plan, and we are going to make a rather a table which can help us record. Right, so that is our plan. Okay, so let's begin with Anil. So we have 3 persons here: Anil, Ben, and Sophia. So what we are doing now is we are carrying out our plans. We have already spelled what we want, right? Now we want to write down when will Anil work. Anil works on the second day. So right, we can write numbers like 2, 4, 6, 8, 10, and so on. Ben works third day. So if we have worked all together today, third day will mean 3, 6, 9, 12, and so on. Sophia works every fourth day. So that means 4, 8, 12, 16, and so on. Now we need to figure out what is common between all 3, correct? That is the whole idea. Well, we need to extend to get a common factor. So we go further, and what we notice here is that we do get a number which is common, which is 12. Do you see that? So 12 is a common multiple of 2, 3, and 4. So when we carried out our plan, we figured out that after 12 days, all will work together, right? So we can write down our results. So when you look back, you had to find same day next time. So the answer here is same day next time will be on the 12th day, right? So that is what it is. And you can actually figure this out, that if you take common fact multiples of 2, 3, and 4, let's check this, right? So 2, 3, and 4, then the multiples of 2 are written here, right? So which is 2, 4, 6, 8, 10, 12, 14, and so on. 3, 6, 9, 12, 15, and so on. And we have 4, 8, 12, 16, and so on. So we do see that we have a common factor 12. Correct? So 12th day, they will actually be together. Correct? You will also notice from this that basically every 12th day, they will be together. Right? So the answer for this for now is, when will they work together again? So 12th day. Now sometimes we can extend this question, next time when? So it is every 12th day, then next time will be 24th day, right? Do you see that? So you notice that in such cases, we have to multiply this by 2, 3, 4 to get the next time when they will be working together, right? So I hope the strategy is absolutely clear. Now you should follow this strategy and then answer the other questions, right? So I hope the strategy is clear. Now we'll actually solve question number 2, which is right before you. I would like you to pause the video, copy this question, use this strategy of UMCL, solve, and then check with my solution, right? We could have different strategies to solve. However, we should get the same result. Perfect. Okay. Here is question number 2 from our set of videos. Question number 2 here is, Abel has swimming lessons every 5th day and diving lessons every 3rd day. If he had a swimming lesson and a diving lesson on October 10th, when will be the next date on which he has both swimming and diving, right? So we'll actually follow this model, which is UMCL model, to answer this question. So the first step here, U means to understand, right? So we'll write down what do we understand from this question, right? We understand that Abel has swimming lessons every. So we're talking about Abel. So we are talking about two things. First is that swimming lessons, which is every 5th day. And then diving lessons, which is every 3rd day, right? So that is given to us, and it's also given. So together, it was 10th of October. Okay. When will be next date on which he has both swimming and diving? So what we need to find is next day together, right? So in short, this is our problem, right? So as you can see here, this is what we are given, right? And this is what we need to find. So I hope you understand the requirement for the question, right? Now let's make a plan, right? So the M in UMCL stands for make a plan. So what you notice here is that we want a common day. So whenever we're talking about something coming together and we are given the frequency or the rate at which it is happening, the best strategy is to find a common multiple. So that is the plan, is to find a common multiple, right? Now there can be different strategies for finding the common multiple. So to find common multiples, what are we going to do? We'll list multiples. To find common multiple. Correct? So that is what our strategy is going to be. Okay, so let's follow the plan, and that is what we say, carry out the plan. So let's write down the multiples for 5 and multiples of 3. Multiples of 5 are 5, 10, 15, 20 and so on, and for 3 are 3, which is not common, 6, 9, 12, 15. Well, we got 15, so we can stop here. So we have a common multiple, which is 15. So we can say that the result, it really means the 15th day. From 10th October, correct? Now let's look back. L stands for look back. So what can we conclude from here? We can conclude that today is 10th and 15th day after 10th of October. So that means we have to add 15 to 10th, right? So when you add 10 to 15, you get 25, right? So that means that it is 25th October, right? That is after, I should say, after 15 days, right? So both swimming and diving will be together, right? Does make sense to you? So that is how, using this strategy of UMCL model, we can actually solve such questions. So I hope that is absolutely clear. Now here is the third question, which is, I have 24 red marbles and 18 green marbles. List all possible rectangular arrangements which I can make using all the marbles. We have to solve this question using the strategy of UMCL, right? So as we have been discussing, U stands for understanding the question, right? So first thing is, we need to understand what is the given question and what do we need to find. So U stands for understand. So here we are given that we have 24 red marbles and 18 green marbles. And what do we need to find? List all possible rectangular arrangements which I can make using all the marbles, right? So we want rectangles with all the marbles. Okay, so somehow when you place all these marbles, you should get rectangles. And how many different ways you can do it, this is what you need to find, right? So different rectangles. You can say different rectangle formations with all the marbles, correct? So there could be variation here, but that's what we're trying to understand this, right? Now for this, how do we make a model or make a plan or make a strategy? So M is to make some plan, right? So let's make a plan. Now in this case, the plan to make rectangles have length and width, right? So what we think about it is that we have to have length and width, right, for rectangle. Correct? So one of them, if it is common, then we can complete the rectangle, right? So we should have something, or we can say rows and columns. We can also call this as length and width, or let's write this as, we are talking about rows and columns. Since we are placing the marbles, right? So you would have them in different rows and different columns. Okay, so or this. Now how do we place them in different rows and columns? Well, the strategy which I think about is, we could have the same number of rows, right? So we have common rows. So we can find common multiples, or 24 and 18. So common number of rows, right, to make this column. So rows will be width here for you, right? So common number of rows. And how can we figure this out? That is to say, common multiples, right? So in other words, we're looking for common factors, correct, of 24 and 18, since these are the numbers given to us. So that is our strategy, correct? Now let's work on this plan. So the plan here, so we write normally, C stands for carry out the plan, right? So we need to find common factors of 24 and 18. So we have 24 red balls and 18 green, right? So let's write down their factors. So of course we can have 1 and 24. So it's kind of a rainbow, right? 1 and 24. We could have 2 and 12, right? We can have 3 and 8. We could have 4 and 6. So these are the factors of 24. As far as 18 goes, we could have 1 and 18, 2 and 9, 3 and 6. Right? So I think that's it. So after that, no more, right? So, okay, 3 and 6. So these are the factors of 18. Now out of these, what are common? Let's highlight those. Well, 1 is common, 2 is common, 3 is common. What else? 6 is common, right? That is it, right? So out of these, we have 1, 2, 3, and 6 common. Okay. Now, how do we make this rectangle? Now we get it that 1 is common, right? So it means what? We have to use all of them together. So when I say 1 is common, there are 24 red and 18 green, right? So, okay, so let's use this as a red color for us. This pink will use that red. So we have 24. So we'll just put them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is a rectangle whose width is 1, length now is 24. And in the same rectangle, we'll put 18 green. So I'll kind of extend here. 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 green. So we get one rectangle, right, whose dimensions are 1 by 18 plus 24, correct? Which is 42. So we have 42 in all, right? So this rectangle dimensions will be 1 by 42, right? So all together. The next combination is with 2. So that means the red marbles will be in 2 rows of 12 each, right? So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Green, 9 and 9, right? So we'll have 1, 2, 3, 4, 5, 6, 7, 8, and 1, 9, right? So we'll just repeat this, correct? So that ways, now we have 2 rows, right? 2 rows, and we have this as 21. So width is 2, so we have 2 times 21. Does it make sense, right? Which is 9 plus 12, half of each. Now with 3, if I divide this by 3, we get 8, right? So we get 1, 2, 3, 4, 5, 6, 7, 8, right? So we'll make 3 rows of 8 each to place our red marbles. Does it make sense to you? Right. And 6 of green, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So in all, we have now 3 rows and 1/3 of each. 8 and 6, 14. Do you see that? We get those many marbles. So in all, there are still 42 when you multiply. Does it make sense to you? The last one here is, let me push this page a bit, to put 6, right, in 6 rows, right? So 6 rows will be, you can extend this, right? So we have 1, 2, 3, 4, 5, 6, correct? And these 6 rows will have 4 of each, right? So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? So that makes it 24 and 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So do you see that? So we have all 18 of them, and we have all of them as rectangles. So in this case, it is 6 times 7, which again gives you 42, right? 4 plus 3. Does make sense to you? So we have made our arrangements, and we have satisfied the condition of making rectangles with these marbles, right? So let's look back. So when you look back, you do have 4 different types of arrangement, right? So we have 4 different arrangements for this particular condition. So one is you can have 1 row, 2 row, 3 row, 6 row, right? So one is we could have 1 row, or we could have 2 rows, or we could have 3 rows, or we could have 6 rows to arrange all the given marbles in a rectangle. Does make sense to you? So that is how we can actually explain it. So I hope all the steps are absolutely clear. Here is question number 4 from our series. The question here is, Amita is making identical balloon arrangements for a party. She has 32 red balloons, 24 green balloons, and 16 orange balloons. She wants each arrangement to have the same number of each color. What is the greatest number of arrangements that she can make if every balloon is used? You can pause the video, answer this question, and then look into my suggestions. You can solve it in many different ways. Now here is the approach which I am going to take. We're talking about UMCL model, in which what we really do is, first step is to understand what the question is, right? So first step is to understand. That is what U means. And then we'll make a plan. So that is for M. Once we have a plan in place, we'll carry out. Perfect. So this is C. And L is to look back. Did we get the right result? Is this exactly what we wanted? So those are the questions you should be asking at the end. Perfect. So that is what UMCL model is. And now let's try to understand the question itself. Now when we try to understand the question, we basically list 2 things. What is given to us and what do we need to find? So these are the 2 things which we need to understand. Given, Amita is making identical balloon arrangements for a party. She has 32 red balloons, 24 green balloons, and 16 orange balloons. So she has 32 red, 24 green, and 16 orange. So this is the color of balloons. She wants each arrangement to have same number of each color. So what we need to find is number of different arrangements where same number of colors are used. Does make sense to you? what is the greatest number of arrangement that she can make if every balloon is used? And we have to use all the balloons, right? Using all balloons, right? So that is the idea. Now, how can we get about this? Well, the strategy could be we know these numbers. So if we find common factors, then we could work it out, correct? So we have to find common factors of 32, 24 and 16, and that should give us a plan for making the arrangements. So let's first find the common factors, right? So how do we find the common factors? Okay, so we list all the factors to find common factors. So the step here to find common factors will be list all factors. Okay, so now we'll apply this strategy. So we have 32 in red, so we have 32 red, right? I'll write red. And factors for 32 will be 1 and of course 32. And then we have 2 and then 16. And you can see 16 is a factor of 32. Okay. So it will go next by 4 times 8, right? 5 it will not go with, 6 no, 7 no, 8. So that means these are all. Okay. So we have 1, 2, 4, 8, 16, 24 as the factors of 32. Now, let's write down the factors for 24, okay, which is the color green. So in 24, again 1 and 24. Let's write 24 here. And then 2 and 12, okay. It goes 3 times, 3 and 8, okay. And goes 4 times, 4 and 6. That's fine. Now 16. 16 orange. 16 is 1 and 16. Then we have 2 and 8. And we have 4 and 4, right? So that makes 16. Now we need to figure out how many are like common in each. So we could have 1 common. We could have 2 common. Okay. We could have this 4 common. What else? We have 8 also common. Right? So these are the common factors in each. So that really means we could have arrangements where we have 1 of each. Right? So that means we have one big arrangement where all of them are together. Right? So this means we have one big arrangement where all are together. Right? So that means it's kind of like this. We have big. This represents all 32 red, and then we have 16 orange, and we have 24 green. So this is one possibility, right? So we have all of them together. Now the second one is we could have now 2 arrangements. When we say 2, we can have 2 arrangements in which half of them are together. Do you understand what it really means, right? So there's one possibility. The second one is we have 2 arrangements now. So that means we have 2 groups, right? 2 arrangements. In which we have half and half distributed. Correct? That really means we'll have, as far as the red is concerned, we'll take 16 of red, half of green is 12, and half of orange is 8, right? So that is what we're going to do, right? Do you see that? So we get this. Now, we could also have an arrangement where we can make 4 groups, correct? So let's make 4 groups now, and then we'll make 8 groups on this side. Okay, so we have 4 groups. 1, 2, 3, and 4, right? So I'll have to push this page a bit so that you could see, right? So, okay, now I hope you can see, right? So we have 4 groups. Right, and then we have greens. Okay. So in these arrangements, 1/4 of each will be placed. So red will be 8, 1/4 of green is 6, 1/4 of 16 is 4, right? So that is what the arrangement is. So we have 8, 6, and 4. So that is the second arrangement. And the last arrangement is, we'll take some space, we'll borrow some space here, right? To make the arrangements, 8 arrangements now. So we have 8 arrangements. So 1, 2, 3, 4, 5, 6. Okay. Okay. So we have, let's say 7, 8. So in each arrangement, we want all the 3 things together. So we have and the green ones, right? So do you see that? Now when you are having 8 different arrangements, the quantity will be distributed. We have to divide by 8 each, right? So the red ones will now be 4 each, right? So 8 into 32 will give you 4. So we have 4 in these ones, the red ones. Is that clear to you? 1/4 of green, 24, is 6. Sorry, 8, we have to 3, right? So 24 divided by 8 is 3. So green will be 3. So likewise, we now know that these are different ways in which we could make the arrangements. And as far as the orange is concerned, it will be 2 each. You see, in each arrangement, we have 2 oranges, 2 orange colored balloons, 4 red, and 3 green. And we have made 8 different arrangements. So I hope that is what was expected from the question, right? So when we look back, what do we notice? When we look back, we notice that what is the greatest number of arrangements that she can make if every balloon is used? So we can make 1, 2, 3, 4, right? So 4 different arrangements. Correct? That is one thing. So in which here we have only one way, 2 ways, 4 ways, and 8 ways. So 8 maximum groups as seen here, right? So that is what we could answer in this particular question, right? So we have kind of split the requirement, which says what is the greatest number of arrangements. So as far as I understand, greatest number of arrangements that she can make if every balloon is used is just this number 1, 2, 3, 4. There are 4 different ways in which to do it. The other way is looking into, if we look into each number, how many maximum in each type. So we could have 8 different, 8 of the same kind. That could be the way, right? So that is how you could interpret and answer this question. So I hope that makes sense. So in this video, we have learned how to solve questions based on a model, right? UMCL model is extremely good model to understand the situation, make a strategy, carry out that strategy, and when you get some results, check, did you get the same result? You can sometimes interpret it in different ways, as we did in the last question, and give your own explanation if you think that the question is not very clear. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.